All right, so this is going to be a video all about vertical asymptotes, and it's just going to be, this whole video is just basically going to be 5 problems to kind of show you what the example problems look like, as well as kind of cement the understanding of the concept behind what a vertical asymptote is. So this first one, it says, what are vertical asymptotes and how are they found? So what I did here is I just actually wrote an answer in rather than trying to handwrite this. I just typed it in really quick. So basically a vertical asymptote is a value of x which causes a rational function to evaluate to a non-zero value divided by a zero value. These x values can be used to form a vertical line where the vertical asymptotes take place. Rational expressions can have asymptotes which are a line that a curve approaches as it tends towards infinity. Okay, number 2, it says, how are vertical asymptotes different from holes? So I wrote the answer in for this one as well. It says vertical asymptotes occur at x values that cause rational functions to evaluate to a non-zero value over a zero value. On the other hand, holes occur at x values that cause rational functions to evaluate to a 0 over 0. So the way I always remember it is the following. If you have an asymptote, it is going to be a non-zero, so something that's not 0 on the top, divided by 0. Okay, a hole, on the other hand, would evaluate to a 0 over 0. Okay, so that's the main difference between them. Now, obviously, they look different on the graph as well, but this is just how they evaluate from like the algebraic side of things, how they're different. All right, number 3, it says consider the rational function f of x. So for part A, it says find the equations of all vertical asymptotes of f, and those are those x values, as I just said, where if you plug them into f of x, it would evaluate to a non-zero over 0. Okay, so you need 0 on the bottom, so the 2 likely choices for this would be where either of these are equal to 0. So if I took x minus 2 and set it equal to 0, I would get x equals 2. So I would check that for vertical asymptote. And then I'm going to do the same thing with this one right here with x plus 3. So x plus 3 is equal to 0. If I solve that out, I get x equals negative 3. So these are the 2 possible things that are going to get us to divide by 0. We just have to make sure that it's a non-zero over 0. So I'm going to plug in 2 to this f of x formula here. So f of 2 is equal to, it's going to be equal to 3 times 2 minus 2, which is 0, divided by 0 times 5. Okay, well this would be equal to a 0 over 0, which is undefined, but since it evaluates to a 0 over 0, it cannot be this x equals 2. In fact, that is where the hole is at x equals 2. So I'm going to answer that for the second part here. Because it's a 0 over 0, it can't actually be an asymptote. We need to look for a non-zero over 0. So we're going to try f of negative 3 this time. So if you plug negative 3 in here, you're going to get negative 2. Because of this part right here, it's negative 3 plus 1. Okay, then it's going to be negative 3 minus 2 right here, which is negative 5. And then we're dividing this by negative 3 minus 2 again is a negative 5. And then we're going to put the negative 3 in here, which is going to be our 0. So here, you would end up with a positive 10 over 0, so that means that it's going to be an asymptote. So this first one is just going to be x is equal to negative 3. Okay, that is where the asymptote is taking place. It asks for the equation of that asymptote. So in this case, it would just be x is equal to negative 3. So I'm going to highlight that as the answer for that one. The next one, it says, what are the x values of all of the holes? Well, a hole, again, evaluates to 0 over 0, and we just did that with this f of 2. So the x value should be x equals 2 for that one, and here is the answer for part B. Okay. Another way of looking at this is a hole is going to be the x value that essentially is the root of how it cancels out in f of x. Okay, so right here, x minus 2 over x minus 2, x equals 2 is the hole. If you notice, that's where it cancels out, that's where the hole is. The x plus 3 right here does not cancel out with anything, so that's going to be the cause of that vertical asymptote since it's in the denominator of the rational function. Okay, so that's number 3. Let's look at number 4. It says find all vertical asymptotes for the following function. So first thing I'm going to do is I'm going to set the denominator equal to 0. So I'm going to say x cubed is equal to 0. And if you solve this, you get x equals 0. And next thing you have to do is actually plug it in to this function. Is f of 0 a non-zero over 0? Well, it would be 0 minus 3 divided by 0 cubed. Okay, this would be a non-zero over zero. So because of that, that would be your answer for the vertical asymptote, is that x equals 0. And last but not least, number 5, it says find the vertical asymptotes for the following function. Okay, so what we're going to do is we're going to set that denominator, x minus 1, we're going to set that equal to 0 and solve. So if you solve that, you get x equals 1. But you need to make sure that f, or in this case g, of 1 is non-zero over 0. So that's what we're going to put in here. We're going to end up with 0 on top times 9 over 0 on the bottom. But if you notice, this equates to a 0 over 0. So because of that, this ends up actually being at a whole, not a vertical asymptote. So the answer for this one is there are no vertical asymptotes. Okay, there is nothing that's going to cause a non-zero over 0 on that, so there are no vertical asymptotes. This video tried to teach the concept of vertical asymptotes using example problems. There will be actually 2 other videos that go over other examples of vertical asymptote problems as well to kind of cement that concept a little bit more. If you have any questions about anything in this video, let me know.